Hello everyone. So the next part of this preparation is the preparation of hydrogen by using dilute acids like HCl and H2SO4, hydrochloric acid and sulfuric acid. We already discussed that we will be using only HCl and sulfuric acid for the lab preparation or while preparing hydrogen. Reason: we don't use nitric acid because nitric acid is a powerful oxidizing agent, and the nascent oxygen means freshly prepared oxygen. Nascent means freshly prepared. Nascent oxygen formed in its decomposition, it oxidizes hydrogen to water. It will not let hydrogen to release during the reaction. What it will do means whenever hydrogen is released, it convert that hydrogen into water. Which one? Nitric acid, because nitric acid is a powerful oxidizing agent. We will study about the oxidizing agent in this chapter itself. And we don't use lead also for the preparation of hydrogen using dilute acids, because lead forms an insoluble coating of lead chloride or lead sulfate, and further the reaction will come to stop. That's why we don't prefer lead for the preparation of hydrogen by metals. Why I'm stressing these 2 points means because these are the one which will be asked for the give reasons and the sometimes question and answers and all those things. Sometimes general preparation methods will be given and these questions will be asked. So very important. Nitric acid, why it is not used in the preparation of hydrogen. Lead, why it is not used in the preparation of hydrogen. So two important points. It is given clearly in the textbook. Please go through that one. So next, we are commencing the preparation of hydrogen or the displacement of hydrogen by magnesium. Why we are not using potassium, sodium and calcium that we have used while preparing the uh, hydrogen by using water, cold water or steam or the boiling water? Why means you know that potassium, sodium, calcium are the very reactive metals, and we have seen that they react even with cold water. They react even with cold water to release hydrogen. If instead of cold water, if you are going to add dilute acids like HCl or H2SO4, the reaction is highly explosive. The reaction is highly exothermic. Large amount of heat will be released, which is not feasible, which is practically not feasible. That's why which is practically not possible to maintain that amount of temperature inside the lab. Sometimes the operators which we are using, they may blast. That's why we don't prefer potassium, sodium, calcium reaction with acids like H2SO4 or HCl because of their high reactivity. So we'll start the reaction of metals from magnesium. In the reactivity series, we'll start with magnesium. Magnesium reacts with HCl to form magnesium chloride. Of course, you can write another reaction for this also. Mg plus H2SO4, MgSO4 plus H2. You can write. And aluminium reacts with H2SO4 to form aluminium sulfate. And zinc reacts with H2SO4 to form zinc sulfate. Iron reacts with chlorine to form iron chloride. These reactions you can, whichever it is given for sulfate, you can write it for HCl, and whichever it is given for HCl, you can write it for H2SO4. That we did already. Okay, so that is what the reaction of metals with HCl or the dilute HCl and the dilute H2SO4 to release hydrogen gas. Next, coming to the very important metals, of course, they are very special: zinc, lead, and aluminium. Zinc, lead, and aluminium. These three important metals we call them as amphoteric. We call them as amphoteric in nature. They react even with acids as well as base to form salt and water. To form salt and water. Last year also we have studied about these three important metals, and of course the reaction of these three metals is also very important. Many times it is asked. So zinc reacts with sodium hydroxide in order to form sodium zincate. Sodium zincate. And lead reacts with sodium hydroxide to form sodium plumbite. Sodium plumbite. Aluminium reacts with sodium hydroxide to form sodium aluminate. If you want to see the radicals of zincate, plumbite and aluminate, you can go for the first chapter where the radicals is given with their valencies, and from that you can practice how to write these reactions that I did already in the classroom. That's why I am telling you. So sodium zincate, sodium plumbite, and sodium aluminate. Very, very important reactions. Three important reactions: zinc, lead, and aluminium. And these are the important general preparations of hydrogen by using water and as well as dilute acids. And below you can see activity series of metals, whatever, which are the metals which reacts with cold water, or which are the metals which reacts with boiling water, steam, and which metals will not react with water or acids in order to release hydrogen. Everything is given clearly. Go through that one. And in the next class we will discuss about laboratory preparation of zinc, and as well as Bosch process, test for hydrogen, uses of hydrogen. Please write these reactions. Try to write the reactions without seeing the textbook. Practice equations. You need to learn all these general preparations, and these are very, very important reactions. Thank you.